Yes. So day 2 class. Yes, yesterday topic, day 2. So about Java. All that Java, what is Java? Why Java got this much of popularity? Java history. And next, what is present position of Java? What is future of Java? And all these points we discussed in yesterday's class. All of these things discussed in yesterday's class. Okay. Yes, what is Java? Java is an OOP language. OOP stands for Object Oriented Programming. Yes, JDK stands for Java Development Kit. So the JDK originally from Sunsoft. Now it is Oracle Corporation. First version of Java, JDK 1.0 is a first version of Java released in year 1995. 1995. Okay. Yes, next. Yes, JDK 1.0. Yes, initial features of Java. They are the initial features of Java. First version of Java 1.0. These are initial features like independent platform, portability, OOP language, scalability, and security. These are initial features of Java. Next version 1.1, 1996. Yes, divided into 3 editions here. Java Standard Edition, Enterprise Edition, Web Edition. Yes, next later the different versions like this. Okay, out of all the JDK 1.5 most important version, JDK 1.5 Java got success. Even yes, 4th edition added in the Java effects. Java effects added in yes, yes in JDK 1. So finally JDK divided into yes 4 editions: Standard Edition, Enterprise Edition, Web Edition, Java effects. Okay. Yes, guys, I'm not feeling well actually. I will explain slowly. Try to understand it here. Okay. Actually, I'm not feeling well today. Suffering some fever. Yes, fever and cold. I'll explain slowly. Try to understand here. Okay. Yes. So Java Standardization, Java technology. This is our course. Okay. Yes. What is enterprise edition? It's application development. So all this. Yes. Frameworks comes under this category. All frameworks comes under this category here. So Java frameworks. All these frameworks. About these frameworks, yesterday we discussed about all the frameworks. What is exactly framework? What is advantage of frameworks? These things we discussed. So this is yesterday topic. Yeah, this was discussed yesterday. Yes, now day 3. Yeah, today let us start with Java features. Today topic this is. Yes, day 3. Yes, day 3. Let us start with Java features. Okay. Let us start with features. Yes, let us start with these features here. See, JDK 1.0 first version of Java released with below features here. JDK 1.0, yes. Yes, it's a first version. First JDK 1.0 released with below features. First version of Java released with below features. Yes, independent of platform, portability, OOP language, scalability, and security. Yes, let us see about all the features here. Yes, independent of platform, portability, OOP language, scalability, and security. Let us see about all these features here. See here to understand these features. Yes, directly may not be understanding these features. Directly, yes, may not be understanding these features here. Yes, before going to these features, let us see some basics. There are some software basics. So we'll see some software basics. Okay. So once you have cleared about software basics here, you can understand these features very clearly. So before going to these features, there are some software basics here, like operating system, like operating systems. What is operating system? Okay. Yes. About OS. About OS. Yes. How OS is working. When you're running Java program, how OS is working. That OS behavior. Okay. Next. Yes, about compiler. What is compiler? So what is compiler? About compiler. Yes, about compiler. Next about interpreter. Compiler and interpreter. Yes, compiler and interpreter. Compiler, interpreter. Compiler, interpreter. Yes, about operating system. About compiler. About interpreter. Yes, next about exe file. Yes, next and about dot class file. Okay, next about low level languages. Low level languages. Next and high level languages. Yes, we'll see all these basics here. So first of all, we'll see all the basics. Once these basics are cleared, then easy to understand these features. So particularly non-IT guys, non-IT background guys, non-IT background guys, yes, basics are important. So once these basics clear, then easy to understand these features. Directly may not be understanding these features. Directly may not be understanding. So let us clear about these basics here. So I'm starting with basics. Yes, starting with the starting with basics here. Starting with basics. Starting with basics. Yes, I'm starting with basics here. Yes, from very scratch. Yes, who don't have the IT background, that case also can understand clearly. Yes, I'm starting from very basics. Starting from very basics here. Yes, who don't have, yes. So who don't have IT background also they can understand. I'm starting from very basics. Starting from very basics. See, yes, very basics. Yes, computer aware. Computer aware. See, computer aware basically two categories. First one, hardware. First one, hardware. Second one, software. First one, hardware. Next one, software. Starting with basics here. Yes, computer aware. Basically two categories. Hardware and software. So what is hardware? Yes, hardware. So these are physical components of a computer. Hardware. Yeah, these are physical components of a computer. We can touch all these parts. Hardware, physical components. We can touch all the parts. Hardware, physical components. Okay. Hardware, physical components of a computer like a hard disk, keyboards, monitor, and all these hardware components you can touch. But this is not ours. Yes, ours is a software. So let us start with software. We are the software engineers. So let us start with software. Let us start with software. Yes, what is software? What is software? See, in software, all are programs. Everything is a program. In software, yes, everything. Yes, everything is a program. Everything is a program. Yes, in software, everything is a program. In software, everything is a program. Yes, it's a collection. It's a collection. It's a collection of programs. It's a collection of programs. In software, everything is a program. In software, yes, yes. In software, everything is a program. It's a collection of programs. It's a collection of programs. Okay. Yes, here software, everything is a program. It's a collection of programs. Okay. Next, software basically two categories. Software basically two categories. Software basically two categories. Software basically two categories. First one, system software. Second one, application software. Second one, application software. System software, next application software. Software basically two categories. First one, system software. Next one, application software. Yes, what is system software? Yes, what is a system software? Let us say about system software. What is system software? System software. Yes, system software. See, it interacts. It interacts with hardware components. System software. It interacts with hardware components. It interacts with hardware components. System software. What is system software? Yes, it interacts with hardware components. System software. It interacts with hardware components. So what is system software? System software, it interacts with hardware components. Interacting with the hardware components. For example, here operating system. Yes, operating systems. Operating systems and device drivers comes in this category. Device drivers. Operating systems and device drivers. Okay. System software, it interacts with hardware components. Yes, example operating systems and device drivers. OS and device drivers comes in this category here. Of course, device drivers are part of OS. Device drivers are part of operating system only here. Device drivers are part of OS. Okay. Next, what is application software? What is application software? Application software, this is for the purpose of application development. This is yes for the purpose. For the purpose of application development. For the purpose of application development. For the purpose of application development. Okay. Application software for the purpose of application development. For the purpose of application development. Applications apps. Yes. In our daily life, we are using some applications, right? Yes, we are in our daily life using some applications. Yes, what is best example for applications? See, in your mobile, many applications are right. There are many applications using. So which is mostly used in your mobile? Tell me, guys. Yes, applications. Which is mostly used application in your mobile? Yes, come on, guys. Yes, application software for the purpose of application. Yes, mostly used application is WhatsApp. 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 So WhatsApp, it's a commonly used. WhatsApp. Yes, very, very important. WhatsApp. Okay. Yes, WhatsApp, Facebook. So these are mostly used applications. Twitter. Okay, next Flipkart. So banking applications, banking. Yes, banking. Yes, banking apps. Next, online trading apps, online trading applications, online trading apps. So these are applications. Phone Pay, Google Pay, go to meeting, go to training. Yes, all the applications, all the online trade, different applications here. Yes, to develop this kind of applications, we need the software, application software. Yes, application software for the purpose of application development. This kind of applications. To develop this kind of applications, we need application software. See, application software for the purpose of application development. For the purpose of application development. Application software for the purpose of application development. Application software for the purpose of application development. Okay, for the purpose of application development. Application software for the purpose of application development. There, this kind of application. To develop this kind of application, we need software here. That is application software. That's it here. Yes, application software. Best example, Java. Java is a mostly used application software. Yes, Java is a mostly used application software. Java is a mostly used application software. Java, next .NET, next Python is also application software. Next C and C++. C and C++, also application softwares. C and C++. Yes, next. Yes, even Hadoop application software. They are application softwares. Next, some databases. So they are application softwares. Application softwares. See, in software, many technologies we are using. Yes, more than 100 technologies we are using. Software, more than 100 technologies we are using. So which is exactly application software? Yes, in software, we are using many languages and many tools we are using and many packages we are using. See, languages like Java, okay, next .NET, C#, Python, C and C++. There are some languages apart from tools like Hadoop related tools, Hadoop big data tools, okay, big data tools, next testing tools, next AWS tools, DevOps tools, like various tools we are using. Next, apart from packages like ERP packages. So many things we are using, right? So which is exactly application software? So which is exactly applications of many technologies we are using nowadays. Many technologies. So which is exactly application software? Which is exactly application software? Which is exactly application software? See, software which is interacts with hardware components is a system software. Yes, which is interacts with hardware, that is system software. Which is not interacting with hardware, not interacting, which is not interacting with hardware, that is system software. Yes, that means only ways. Only ways can interact with hardware. Only ways. Only operating systems can interact with hardware components. Operating systems like Windows OS, Linux OS, Unix OS, Solaris and Mac. So these are operating systems, right? Yeah, these operating systems can interact with yes, hardware components. So except OS, all are applications. Simple. Yes, very simple here. Yes, except operating systems. Except operating systems, all are yes, except operating systems, all are application softwares. All are application softwares. All are application softwares. All are application softwares. Except OS. Except operating systems, all are application softwares. Except operating systems, all are application softwares. 1 second. Yes, about your class notes. See, running notes is not necessary. You guys, running notes is not necessary. I have prepared clear documents. Very clear documentation is there for every topic. Yes, clear document is available. Yeah, this is today topic. Yes, today started from the scratch. See, last two classes, all the introductions finished. Only introductions. Today, actual classes started. Topic started from the scratch. Okay, started from the beginning here. Okay, so first finishing all the basics, next moving to Java. Yes, today topic software. Yes, software is a collection of programs. Okay, such as C, C++, Java, and other programs here. Software basically two categories: system software, next application software. System software, yes, it interacts with hardware components. Example, device drivers and operating systems. System software, next application software. For the purpose of application development, application software for the purpose of application development. Example, C, C++, Java and all this here. C except operating systems, all are application software. Same topic explained. Same topic we discussed. Okay. Yes. Right. So except with all our applications. Okay. Yes. So today day 3. Yes. Actually features. Yes. Features. Before going to features here, there are some software basics. Like what is ways, what is compile interpreter, what is exe file, what is dot class file. Next about low level language, high level language, these things here. Okay, starting with basics. So starting with basics here. Yes, computerware. Computerware basically two categories. Computerware basically two categories: hardware and software. Hardware and software. Yes, hardware. These are physical components of a computer. Hardware, physical components of a computer. Yeah, that is not necessary for a software. Yes, let us start with software. Software, everything is a program. It's a collection of programs. It's a collection of programs. Software basically two categories. Software basically two categories. First one, system software. Next is application software. System software, application software. See, system software, yes, it interacts with hardware components. System software, it interacts with hardware components. Examples, OS and device drivers, operating systems and device drivers. System software, it interacts with hardware components. Yes, examples, OS and device drivers. Okay. Yes, application software for the purpose of application development. For the purpose of application development, applications like WhatsApp and all these in the applications, right? To develop this kind of applications, we need this application software. Okay. Yes, example Java, .NET, all these are application softwares. Yes, many languages, tools and packages. See, except OS, except operating systems, all are application softwares. All are application softwares. OS, like Windows OS, Linux OS, Unix OS, Scholars, there are different operating systems here, except OS, all are application softwares. So this is about application software. Yes, let us see about OS. What is exactly OS? Let us start with OS here. So what is OS? About OS. See about OS. See operating systems. Yes, let us see about OS here. This is important point to understand Java features. Yes, some question for you guys. Some question. Yes, can we run any program without OS? Without OS. Yes, say yes or no. Your answer. Can we run any program without OS? Can we run any program without OS? Yes, come on guys. Can we run any program without OS? Yes, of course, just I'm asking your idea. Of course, I'll explain everything clearly. I'll explain all clearly. Can we run any program without OS? Yes, answer is no. Answer is no. Okay, answer is no. See, except bias. Except bias. Except bias to run all programs OS requires. To run all programs OS requires. OS requires. To run all programs OS requires. Except bias. Okay. Yes. Except bias. Except bias to run all programs OS required. Except bias. For bias, yes, OS is not required. Except bias to run all programs OS required. What is bias? What is bias? Bias stands for yes, basic, yes, input and output system. Bias stands for basic input output system. So bias stands for basic input output system. Bias stands for basic input output system. Okay, right? Yes, what's a task of bias here? Bias stands for basic input output system. What is exactly bias? Bias is a hardware level program. Bias is a hardware level program. Okay, it's a chip level. Yes, it's a hardware program. Yes, it's a chip level program. It's a chip level. It's a chip level program. Okay, it is bias chip. So from the bias chip, see bias, it's a part of motherboards. Bias chip. One second. Yes, bias that image. Yeah, this is bias image. You can see that bias. It's a bias in yes in motherboard, right? Bias. So what's the role of this bias here? What's the role of bias in system here? Bias is responsible for what here? Bias. Say bias is responsible. Bias is responsible. Bias is responsible. Yes, bias is responsible to boot operating system. To boot operating system. To boot operating system. Bias is responsible to boot operating system. To boot OS. Okay, bias is responsible. Bias is responsible to boot operating system. Okay, so what is booting process? What is booting? Yes, booting. What is booting? Booting is a process. Booting is a process of loading. Booting is a process of loading. Yes, loading OS from yes hard disk to RAM memory. That's it. RAM memory. RAM memory. Okay, so booting is a process. Booting is a process of loading OS from hard disk to RAM memory. Okay, yes, once you power on system here, when you power on system, first of all, power goes to BIOS. When you power on your computer, here, so first of all, power goes to BIOS. Okay, so that BIOS program loads OS from hard disk to RAM memory. See that BIOS program. So once you power on your system here, first of all, power goes to BIOS program. That BIOS program, Yes, loading OS from hard disk to RAM memory. So once OS loaded into RAM memory, your system is ready. Your system is ready. So once, okay, once OS loaded into the RAM memory, your system is ready here. It's a booting process. Yes, OS loading from hard disk to RAM memory. It's a booting process. Now where this RAM, yeah, where this OS is running? Tell me guys. Now where this OS is running? See, when you power on your system, when you power on system, okay, first of all, power goes to BIOS program. That BIOS program loads OS from hard disk to RAM memory. So once loaded here, our system is ready. Now where this OS is running here? Yes, where this OS is running? Yes, is it a hard disk or RAM memory? Where the OS is running here? Yes, here OS, Windows OS running. Where is running? Is it hard disk or RAM memory? You see, hard disk is for the storage. Hard disk is for the storage. Okay, C drive. In C drive, OS is available. So hard disk is for the storage. Okay, RAM is for the running all this. All OS and BIOS and OS and all programs running in the RAM memory. So this OS is running in the RAM memory. So here OS is running in the RAM memory. So OS always will run in the RAM memory here. Yes, hard disk is for the storage. Hard disk is for the storage. OS is for the processing. So hard disk is for the data storage. OS is for, yes, RAM is for the, yes, data processing. RAM for data processing. Hard disk for the storage. Okay. Yes. So currently OS is running in RAM memory. OS is running in RAM memory. See, booting is a process of loading OS from hard disk to RAM memory. So hard disk is for the storage. RAM is to run the OS. So everything happen in, yes, everything happening inside the RAM memory only here. Runtime process. Everything happens in RAM memory. RAM memory. Okay. Yes. So what is exactly OS? So here OS running in RAM memory. So what is operating system? Now let us see what is, yes, what is operating system? Yes, what is operating system? Let us say about OS. What is operating system here? What is operating system? Yes, what is waste? Let us say about waste here. What is exact waste? What is operating system? See, computer. Yes, in computer. So first of all, there is a hardware layer. Yeah, there is a hardware layer. There is a hardware. In computer, there is a hardware. On top of hardware, OS is running. Yes, operating system.
Hello. We are not able to hear you, sir.
Hello. Hi there. Good morning. Yeah. Actually, Abhishek provided actually. Uh, but Abhishek provided 7 admin. Yeah, 7 admin. Okay, actually, you're in leave, right? So instead of this, oh, okay. Okay, fine. Oh, yeah. Actually, only except one application, right? Just CXOC prod. I morning only I got the access, but only this pending. No, now Abhishek given that time. Yeah. Yeah. In which environment? Yeah, Parita Salva, Cambridge, right? Cambridge actually, but
Yes,
Microsoft
yes. Can you hear me now?
is going on.
Hello. Can you hear me now?
That actually is the new
Yes, you are audible
new
now.
No, it's
UI is
audible, right?
not coming up.
Yeah.
That's the actual
Yeah.
Yeah.
Unexpectedly, yes. Unexpectedly, some network is down or system also shut down on it.
Exactly.
I have resigned. Okay, fine.
I,
Thank you.
I, I think actually DevOps is DevOps
Please
actually
keep on muting, all of us.
I think
Yeah.
after
Yeah.
this.
I'm meeting everyone. Just, yeah, muted everyone. So, can you hear me now clearly? It's clear, right? Okay. Yes, let us continue session. Let us continue. Yes. So, this is the topic what we discussed till now here. Yes, hardware. Just a minute. Yes, hardware. On top of hardware, there's a OS. On top of OS, all these are running. Yeah, these all are. Yes, all these are application softwares. Yes, all their C plus all these application software running on top of OS. See, except OS, all are application softwares. H. Except OS, except operating systems, all are application softwares. except OS, all are application softwares. So these application softwares running on top of OS means the OS giving platform. Okay, yes, OS giving platform. So OS giving platform. Okay, so OS giving platform. Okay, on top of OS, all the programs running. On top of OS, all programs running here. All the programs running. So OS giving platform means acting like a platform. So OS is acting like a platform. Okay, yes, it's a platform. OS is a platform. So what is exactly OS? OS, yes, it's a platform. Yes, it's a platform. It's a platform. Yes, where we can run all the application softwares, all the application softwares. It's a platform where we can run all the application software here. Yeah. So what is OS? Yes. So what is OS? So what is OS? Means simple answer. It's a platform. It's a platform where we can run all the application software. It's a platform. It's a platform where we can run all the application software. Yeah. See, not only platform, not only platform. Suppose C program generating some output. C program or C plus this program generating some output here. So output of these programs first of all delivered to OS. Output of all the programs first of all delivered to OS. Okay. Yes. Once again. Yeah, definitely. See, this is your class document. 1 second. This is your class document. So this is today topic. See, about waste. Today topic. This is about waste, right? So whatever we are discussing, everything clearly it's in document. This document for you only. This document for you only. See, for explanation purpose, sometimes I'm using Word document. Sometimes I'm using Word. On the Word, I'm explaining sometimes. Sometimes I'm using Notepad. Notepad for explanation, right? So different things I'm using for explanation. So what are the topics explained? It's there in document very clearly. Okay, in document very clearly it's there. In document, it is document for you only. Just to follow the document here. So running notes is not necessary. Just to follow the document. This document for you only. I'll share this document. Okay, this document for you only. I'll share with you. Okay. Yes, drive access will begin in drive. I'll place this document. This document development drive here. Download from the drive. This document you can download it. This document is for you only. So every topic I have prepared like this. Even single liners not missing. So what are we are discussing in the notepads and Word. So what are the points we are discussing? I'm explaining the notepad word here. Same thing you can see exactly in our class document. Even single line are not missing. Next, one more thing, my order of explanation, document order is both are same. My order of explanation, document order is both are same. Even single line are not, yes, not mismatch. Everything same, no mismatch. So same as my order of explanation. So this document order, my class order same. Yes, no worry. Same this document you can follow. After finishing class, just read the document for the same topic. Okay, so same what we are discussing in the class here. So what I'm explaining here, same thing it's in document, just to follow document here. So what is operating system? What is operating system? Yes, it's a platform. It's a platform where we can run all the application software. 1 second. Yes, it is a platform. It's a platform where we can run all the application software. Where we can run the application software. See, not only platform here. Suppose C program generating some output or Java program generating output, some Python scripting generating some output. So first of all, output goes to OS. Output of all these programs delivered to OS, and then transfer to output device, transfer to output device. Suppose if it is reading from the keyboard, C program or Java program reading from the keyboard. First of all, keyboard data goes to OS. First of all, keyboard data goes to OS to your programs. So between application software and hardware, there's a OS, like a mediator, So exactly you can say it's interface. Interface. OS is interface between application software and hardware components. Okay. Yes, it is an interface. It is an interface. It is an interface. It's an interface. It's an interface. It's an interface. It's an interface. Yes, between. It's an interface between application. It's an interface between application software. Yes, application software and hardware components. And hardware application software and hardware components. Okay. So OS, it's a platform where we can run all the application software. Next, it's an interface. It's an interface between yes, application software layer and hardware components. That's it here. Yes. Next, one more point about OS. In OS, there is a library. Yes, in OS there is a library here. Inside of OS there is a library. So library, it's a collection of input-output functions. Library contains all input-output functions here. It contains all input-output functions. Library, yes, in ways, every ways there is library. Every ways has its own library. Okay, yes, every ways has its own library to communicate between application software, hardware components. Communication between application software, hardware components. So OS using library. So there is a library. That library is a input-output functions. Input-output functions. Functions means C language functions. C language functions here. See, every way is developed in C language only. Every way is developed in C language. Like Unix ways in C language, Linux ways in C language, Windows ways in C language, Mac ways in C language, Solaris ways, like this, all the operating systems in C language developed. So these are C language functions. Okay, that library is a collection of C language functions, input-output functions to perform IO operations. So library contains input-output functions to perform IO operations between application software and hardware components. Okay, see every ways has its own library. Every ways has its own library to communicate. Yes, every ways has its own library to communicate. Yes, between yes, application software, this layer, application software layer and hardware components layer. Hardware components, right? Hardware components, application software and hardware components here. Okay, see here, OS using library. With the help of library only, yes, OS can communicate between application software and hardware components. Next, one more important point, Java perspective. In Java perspective, one more important here. See, these programs, what happens here, before going to run these programs here, first of all the programs linking with OS library, first links with OS library, after linking communicates with hardware components. Okay, yes, maybe C program or C++ program or Java program, Python. Yeah, these programs first of all linking with OS library. After linking with OS library, communicates with hardware components. It has to link. So before going to run these programs, all the programs, these programs linking with OS library. After linking with OS library, then execution starts. Okay, so every program has to link with OS library before going to run it here. Okay, next, one more important point here. Yes, in Java perspective, one more important point here. See, every program has to link with OS library. It has to link with OS library. Every program has to link with OS library. Yes, before going to start, before going to run here. Okay, before going to, it has to link compulsory. Otherwise cannot communicate with hardware. See, to communicate with hardware components, these programs linking with OS library. So all the programs, every program, first of all linking with OS library, half linking with OS library, then communicates with hardware components here. Okay, so communicates with the hardware. So every program has to link with OS library before going to run here. Before going to run here. Okay, every program has to link. It has to link. So every program has to link. Just remember this fourth point here. Try to remember this one here. Every program has to link with OS library before going to run here. That's it here. See, today's topic. Yes, in document it's there here. Running notes is not necessary. Just to follow document here. See about OS. Yes. First question, can we run any program without OS? No here. See, except BIOS. Except BIOS to run all programs OS required. BIOS stands for Basic Input Output System. So BIOS is a hardware program. It's a chip level program. Yes, BIOS is responsible to boot operating system. See, booting is a process of loading OS from hard disk to RAM memory. Yes, all the same points exactly we discussed. So what is OS? These 4 points. That fourth point, every program has to link with OS library. Okay, OS library before going to run here. Before going to run here. See, hardware, on top of hardware, OS library, then application software. That's it. Here. So this is today topic. Okay, library contains all input output functions. Manisha, library is a collection of input output functions. Library contains all input output functions to perform IO operations. Library is a collection of input output functions to perform input output operations. Okay, it contains all input output functions to perform IO operations. Input output operations. That's it here. Input output operations. Okay, fine. Okay, yes. Now, okay, see, software. Yes, basically two categories. Okay, yes, system software, application software. Yes, system software explained clearly, application software explained clear here. Now, what is Java? Java comes in what? System software, application software. What is Java? Is it system software or application software? Java is application software, right? As per our discussion, Java is application software. Java is application software. So let us move to application software. Yes, application software. See, application software basically two categories, front end and back end here. Application software basically two categories here, front end and back end. Front end, back end. Front end, back end. Yes. What is front end software? What is back end software? Front end software, back end software. See, front end. See, 1 second. Yeah, this is front end. Right? This is front end. Here is a form. Here is a form. Okay. Here a form, right? We are filling form. Just we are filling form and submitting. Yeah, this is called as front end here. Yeah, this form is a front end. Okay, this is called a front. So front end taking data. So this data storing in some location. Yes, front form, the registration form. It's a registration form taking your data and storing it some location. Okay. Yeah, this is called as front end. So front end taking data from us, right? Is taking data from users here. Front end taking data from users. Okay. So front end interact with users. Front end interacting with the users, taking data from users and storing into some location. That location is called as backend. So backend is a data storage. Backend is to store the data. Backend is to store the data. Front end is to interact with users. Front end interacts with users and collecting data from users and stores into backend. Okay. See, front end, backend. See, front end, backend. Front end. So these are to interact with users. It collects data from users and stores into backend here. Stores into backend here. So backend, yes, to store and maintain data. Example, databases. Databases and files comes on backend here. So backend is to store data, store and maintain data. Front end is to collect data from users. Now, what is Java? Is it front end or back end here? What is Java? Is it front end, back end here? Okay. Yes. What is Java? Let us see. See behind of this form. Here behind of this form, there is a Java program. See behind of this form, some Java program. That Java program taking data. Behind of this form, this is Java program. Java program taking data, storing to database. So Java program taking data from us, right? Java program with the help of forms taking data. So Java program taking data from us. That means it's a front end. So Java is a front end. So interacting with users, taking data from users. So it's a front end here. Okay, backend is to store the data. Backend is to store the data. So this is front end. This is front end here. So here, so Java comes on the front end. Java is a front end. Java is a front end. Okay, so Java comes on the front end here. See, application software. Yes, front end, back end. So Java comes under front end. Java is a front end. Java is a front end. Okay, yes. Now let us move to front end. Let us move to front end. See front end. One second. Let me have some water. Let me have some water. It's fine. Yeah, let us continue. Front end. In front end again two categories: language and packages. See, package is ready-made and ready to use. For example, MS Office is a package. Tally accounting is a they are packages. Packages. Okay. Yes. Language. In language, we should write the coding. Programmer has to write the coding. So Java comes in languages. Our topic is language. Let us move to language. See, the way of introducing it to Java. Try to observe that introduction here. Yes, introducing it to Java. So first start with basics, software. Okay, some basic started software. Software two categories: system software, application software. Java is a application software. So that's the reason. Yes, move to application software. So before coming to application software, about OS explained clearly. How OS is working, that's clearly explained. Okay. Yes, now application Java is application software. So started application software. Yes, in application software, there's a front end, back end, front end, back end. Okay, Java is a front end. So that's the reason moving to front end. In front end, there are languages and packages. Language. Okay, Java is a language. Java is language, so moving to languages. Now topic is about language. Yes, language. See, what is language? It's a media of communication, right? Language is a media of communication. Fine. Okay. Yes. Software languages. Software languages. Software languages. See, in software, yes, computer understanding some language, right? Computer understandable. Computer understandable. Computer understandable language. Computer understandable language. In software, computer understandable language. Next, user understandable language. Yes, we are understanding some language, computer understanding some other language here. So computer understandable language different, our language different, user understandable. So computer, first one, computer understandable language. Second one, user understandable. See, user understandable means like a C program. For example, C program. So these are some C programs. Okay, C programs. C program looking like English, right? C program looking like English. So this is user understandable language. User understandable language. Suppose one more example, Java. Java program. Let us take some Java program. Java program also looks like English language. Java program. 1 second. Java program. See, this is Java program. Okay, this also looking like English, right? Java program looking like English language. It's a Java program. Okay, so these are user understandable language. C program, C++, Java looking like English language or user understandable language. User understandable. Okay, yes. See here, computer understandable language. So what is, yes, user understandable language like English language. So what is computer understandable language? What is computer understandable language? See, computer understandable language. Computer understandable language. Yes, it depends. It depends. It depends on generation of computers. It depends on generation. It depends on generation of computers. It depends on generation of computers. Yes. Here's some question for you guys. Some question. How many generation of computers? 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 Yes, anyone can you answer this? How many generation of computers? See, computer understandable language depends on generation of computers. Now your question, how many generation of computers? How many generation of computers? Yes, Amjad, good. It's a 5 generations, 5 generations, 5 generations. Yes, there are 5 generations. Okay, there are 5 generations. There are 5 generations. 5 generations. Yes, first generation. First generation computer. What is first generation computer? It's a vacuum tubes. Vacuum tubes based. Okay. So first one vacuum tubes based here. Vacuum tubes. First one is vacuum tubes. Okay. Second generation. Second generation. Second generation. Second generation transistor based. Transistor based. Second generation is transistor based. Second generation transistor based. Next, what is third generation computer? Third generation computer. Third generation computer is IC based. IC based. Integrated circuits. Integrated circuits. IC based. Fourth generation. Fourth generation. Fourth generation is a processor based. It's a processor based. Yes, this is present generation. This is present generation. Okay. So first generation vacuum tubes. Second generation transistor based. Third generation IC based here. Yes, fourth generation it's a processor based. It's a present generation. Okay. Yes, fifth generation. Yes, it's a future. Yes, what is future generation computer? Shall we get anyone idea? Future generation computer. Future generation computer. Future generation AI. AI based. Good. Good. Hamza. AI based. AI based. AI based. So AI based computer. Yes. What is processor based? Understandable language. Present generation is processor based. Now we are using processor based computer. Yes, processor based. So processor based computer understandable language. So what is processor based computer understandable language? Processor based computer understandable language is a binary code. Binary code. It's a binary code. Binary code. Is a binary code. It's a binary code. Okay. Binary codes. Binary codes. Just like a zeros ones formats. Okay, I'll show practically what is binary codes. I'll show clearly. So this is binary codes. Okay, binary code. Processor based understandable language. Processor based computer understandable language is binary code, like a zeros ones formats. See, AI based. So what is AI based computer understandable language? See, AI based computer understandable language is a, yes, what is AI based computer understandable language? Anyone idea? Is English. English, it can understand English. Yes, AI based computer understandable language, it's English. It can understand your English here. Yes, or English it can understand here. Yes, if saying something here, it will work automatically here. Okay, suppose automation. Yes, automated home. Suppose your home automated. Automated. When you speaking something automatically, that computer will recognize. Okay, suppose something you want to start. Suppose TV, starting TV. Okay, switch on TV, switch off TV. Okay, automatically happens here. Okay, using VA based computer here. Okay, suppose yes, lights off on, auto door open, close, automatically happens here. Okay, you have to tell some keys. Suppose car automized with AI computer. Yes, car automized with AI computer. Okay. Yes, when you want to open, yes, some door. Need not to open, yes, need not to open manually here. Yes, say some key that opens automatically. Suppose sunroof system car. When you want to open the roof, just say something key that opens auto. Yes, something like Alexa. Okay, something like Alexa. That is. Okay, that is AI based. AI based. It can understand English. Okay, it can understand English. Yes, something like Alexa. Okay, yes. So AI based computer understandable language English here. It can understand our English very clearly. Okay, once AI based come to the market here, yes, our things becomes very easy here. Okay, maybe next couple of years chance of getting into market, but it's a costly. AI based computers are very costly. Costly. It's not easy to purchase. Costly. Okay. Yes. So these are different generation of computers. Okay, different generation of computers. Okay. Yes. Processor based computer understandable language binary code. It's a system understandable language. This is called as low level language. This language called as low level language. Yes, user understandable English. C program. It's English, right? Yeah, this is yes, user understandable language called as high level language. High level language. So languages are basically two categories. See here languages. See languages. Languages are yes. Languages are two categories. Two categories. Two categories here. Yes. First one low level languages. Low level. Low level languages. Low level languages. Low level languages. First one low level languages. Second one high level languages. Second one high level languages. Low level language and high level language. Low level and high level. What is low level language? What is high level language? Low level language. Low level language. It is a system understandable language. It is a system understandable. It's a system understandable. It's a system understandable language. It's a system understandable language. Yes, yes. It is in the form of binary code. In the form of binary code. Binary code. It is in the form binary code like zeros ones. It's in the form binary code. Okay. Here system is a processor. System means it's a processor. System means it's a processor. System is processor. Yes, it is a processor understandable language. It's a processor understandable. It's a processor understandable language. It's a processor understandable language. It's a processor understandable language. Okay. See processors. Yes, processors. See 8085. Yes, 8085. Yes, before 90s. Now we are using 8086 processor. They are the processors. Before 90s, 8085. Okay. After 90s, we are using 8086 processor. Yes, processor means microprocessor. It's a microprocessor. Microprocessors. Yes, microprocessors. Microprocessors. Okay, 8085, 8086. Okay, now currently we are using 8086. Okay, yes, it is called as machine language. Yes, it is called as machine language. It is called as machine language. It is called as machine language. Yes, it is called as machine language. Okay, so low level language. It is a system understandable language. It is in the form of binary code, zeros ones format. System means a processor. It's a processor understandable language. It's a processor understandable language. Yes, yes, processor means like 8085, 8086. Now currently we are using 8086 here. Yes, it is called as machine language. So they about low level language. Next, high level language. What is high level language? Yes, it's a user understandable language. High level language. Yes, it is a user understandable language. Yes, it is a user understandable. It's a user understandable language. It's a user understandable language. Yes, it's a user understandable language. High level language. It's a user understandable language. Yes, it is. See, it is like English language. Yes, it is like English language. It is like English language. It's like English language. Like English language, very easy to understand. It's like English language. Yes, it is very easy to understand. Very easy. Very easy to understand. Very easy to understand. Very easy to understand. This language very easy to understand here. Understands. Very easy to understand here. See, example. Java is a high level language. Java program. English looks like English. C program. Yes, C++. Python. Okay. Yes. Next. .NET. .NET C Sharp. Okay. Yes. Next. HTML. There are all the languages. High level language. Okay. High level languages. Okay. All are looks like English language. See the C program. It's a C program. It's looking like English language. It's like English language, right? It's like English language. Okay. Suppose Java program. See this Java program. This are looking like English language. It's English language. English language, right? Okay. Looking like English language. So these are called as high level languages. High level languages. C program, C++, Java, Python, yes, HTML, some Scala, like these various languages. These all are high level languages. Yes, here some question for you guys. Some question. Which is first developed? Which is first developed? Which is first developed high level language? Which is first developed high level language? Anyone can you answer it? Which is first developed high level language? Yes, anyone can you answer this? Which is first developed high level language? Which is a first developed high level language? Yes, Amjad, good. Yes, C language. C language. C language is a first developed. C language is a first developed high level language. First developed high level language. Yes, high level language. By whom? By whom? Who has developed? C language is a first developed. C language is a first developed high level language. By whom? Who has developed C language? Anyone idea? Who has developed C language? Who has invented computer? Tell me guys. Who has invented computer? Who has invented computer? Who has invented computer? Charles Babbage, right? Computer by the Charles Babbage. Computer Charles Babbage. Okay. C language. C language. Who has developed C language? Yes, Dennis Ritchie. Dennis Ritchie. Yeah, this is by Dennis Ritchie. Dennis Ritchie at 80 Bell Labs ESA. Bell Labs ESA. Yes, in the year. Yes, in the year 1972. In the year 1972. C language is a first developed high-level language by the Dennis Ritchie at 820 Bell Labs ESA in the year 1972. Okay, C language is a first developed high-level language. It's a first developed high-level language by the Dennis Ritchie at 820 Bell Labs ESA in the year 1972. Okay, it's a first high-level language. Okay, yes. See here, C program, Java programs. See Java program. It's a high-level language, right? Now this code Java. This is Java code. This code has to convert into binary code. After converting into binary code, then program executes. Every program code has to convert into binary code. Every high-level language, maybe C program or C++, Java or Python. All the programs, high-level language. Yes, high-level language. Yes, high-level language to binary codes. We will convert it here. Every high-level language program has to convert here. So high-level language to binary codes. Yes, which one will convert from high level language to binary code? Anyone idea? High level language, C program to binary codes, Java program to binary codes, C++ program to binary code. Every high level language code has to convert into binary code. Yes, which one will convert? Which one will convert from high level language to binary code? Anyone idea? This case, which one will convert from high level language to binary codes? For this, yes, for this compilers, no, processor understandable language is binary code. So this high level language has to be converted to binary code. That binary code given to processor. Yes, binary code given to processor. Okay, binary code is a processor understandable language. That high level language code has to be converted to processor understandable language. Who will convert it here? For this, which one will convert? Compilers and interpreters. Compilers and interpreters. Compilers and interpreters. Converts, converts, converts from high level language to binary. From high level language to binary. From high level language to binary. Yes, compilers or interpreters. Compilers and interpreters. See, compilers and interpreters converts from high level language to binary codes. After converting to binary code, then program execution starts. Yes, compiler, interpreter. Yes, what is compiler? What is interpreter? Yes, both are to convert high level language to binary codes, but some difference is there. Yes, what's the difference between compiler and interpreter? Yes, we'll discuss. Wait. Yeah. So let us repeat today's topic. Today's topic. See, yesterday, day before yesterday, all the introductions were discussed. About course introduction discussed. So next, about Java introduction discussed here. Yesterday, complete Java overview discussed here. Today, yes, started from the scratch. Started from the scratch. Okay, started with software. Yes, software is a collection of programs. Yes, software basically two categories: system software, application software. System software, it interacts with hardware components. Example, device drivers and operating systems. Yes, application software for the purpose of application development, application like WhatsApp, Facebook, that kind of applications. Okay, their application softwares. Except OS, except operating systems, all are application softwares. Java is application software. Java is application software. So before going to application software, something we discussed about OS. About OS. Okay. Yes. Except BIOS to run all programs OS requires. BIOS, basic input output system, is a hardware program. Yes, BIOS is responsible to boot the OS. Booting is a process of loading OS from hard disk to RAM memory. So what is OS? About OS very clearly explained. It's a platform. OS is a platform. On top of it, all are running here. Okay. Next. Yes, Java is application software. Java is application software. So moving to application software. Yes, application software, two categories: front end, back end. Java is a front end. So moving to front end. In front end, language and packages. Java is language. So moving to language. In language, low level language, high level language. See this software language, computer understandable and user understandable. Yes, computer understandable language. Computer understandable language, it depends on generation of computers. There are 5 generations. There are 5 generations. 5 generations. Okay. Yes. So first one, yes, processor. Yes, 5 generations. Present generation is processor based. Processor based is what? Binary code. Yes, it's a system understandable language. System is a processor. Okay. Yes, AI based understandable language. It can understand high level language like English and Java and Python also it can understand here. Okay. Yes, software language. Yes, see backend of AI based computer, Java, R and Python backend. Backend of AI based tools. A backend of AI based tools is yes R language, Java and Python. Backend. Backend of AI based. Okay. Yes. Software language, two categories, low level, high level languages. Low level languages, about low level language, clearly explained here. Next, about high level language, clearly explained here. Okay, same what we discussed here. What we discussed, same thing explained very clearly here. What we discussed till now here, it's there in document here. Just you can follow document here. Okay, see running notes is not necessary, just follow document here. This document for you only. Yes, yes, I'll give the drive access. But tomorrow I'll be giving drive access for all of you guys. Tomorrow drive access. Okay. Yes. See here, compilers and interpreters are used to convert from high level language to binary code. Binary codes. So difference between compiler and interpreter. So what's the difference between interpreter and compiler? Interpreter and cover the differences. This topic tomorrow we'll discuss. Yes, tomorrow we'll continue for this topic here. Yes, tomorrow interpreter and compiler after starting Java. What is Java? Is it compiler based or yes, interpreter based? So this topic tomorrow starting Java concepts. Today just basics discussed here. That introduction basics discussed here. Tomorrow will be starting Java concepts. Okay. Yes. Sir. Yes. Once again. Yeah. What is kernel? Okay. It's a part of kernel. Is a just it's a core component of OS. That kernel contains device drivers and OS library. Kernel. Yes, it's a OS core component. Kernel is a core component in the OS. Yes, core component, core part of OS. See kernel. Yes, this is Linux document. Yes, sometimes I'm taking Linux classes also. Kernel. One second. This is kernel. Yes, OS architecture. You find the kernel topic. Linux architecture series kernel. Hardware. Yes, on top of hardware, they say OS. In OS, they say kernel and shell. Kernel. So kernel contains two parts, libraries and device drivers. This is kernel. There are two layers in the kernel. So one is device drivers, another one libraries. Device drivers are to communicate with hardware components. Libraries are to communicate with your C program and C plus Java. Okay. So C and C program, C plus Java, all the programs sending data to library to device driver to hardware component. That's it. Suppose C program delivering data. The data first of all goes to library. That library to driver to hardware. That is kernel exactly. So these two parts is a kernel. This is kernel. Okay, OS kernel contains libraries and device drivers. That's it. Hardware kernel libraries. I think it's clear, right? Okay. Yes. So next topic about interpreter and compiler. So this topic tomorrow will continue here. Yes, after finishing interpreter and compiler, next topic starting Java. Tomorrow entering the Java concepts. Yeah, that's all for today. That's all. Yes. Any doubts, guys? Any doubts? No doubts, right? Yes, if no doubts, let us wind up session for today. Okay. Let us wind up session for today. So thank you, guys. Okay. Yes, see you tomorrow.